Hi everyone, this is Karthika, Faculty of Physics, working in SNS College of Technology. So in this session, I am going to explain about the spontaneous and stimulated emission and then the population inversion. So this comes under the laser topic. So here we can understanding the light matter interaction. So first before we are going to discuss about the emission process, so we should know how do atoms interact with electromagnetic radiation, and then understanding emission process is the key to modern photonics from LEDs to quantum computing. And then the design thinking begins with empathy. We must first understand the fundamental behavior of excited atom before we can innovate. So here we can see the three types of emission, that is spontaneous emission, stimulated emission, and then the absorption. So here absorption is nothing but by applying the external energy, the ground state atoms absorb some energy from the external energy and moves to the ground state to excited state. So here the rate can be have the B12, that is transition from ground state to excited state means so 1 2 the transition. And the spontaneous emission is nothing but without giving any external energy, the atoms from the excited state moves to the ground state by emitting the photon. So here that is not denoted by A21. So A21 indicates the transition from excited state to ground state, that is N2. So stimulated emission is nothing but by giving external energies to the excited state, so that will induce the another photon to transit to the ground state. So though the transition can be taken as B21, this is nothing but A and B is nothing but a constant, so that is called the Einstein's coefficients. So we can we have the derivation for this. So here we can see the brilliance of stimulated emission. So key properties is there. So phase coherence with incident photon and same frequency and directions. So amplification mechanism and foundation of laser technology. And Einstein's relation we can see, that is A21 is equal to 8 pi h nu cube by c cube B21. So this is nothing but comparing with the Planck's constant we can derive the Einstein's relations. So this is the elegant equation that connects spontaneous and stimulated process, so that revealing the nature's balance. So population inversion means to have the emission process, the atom should be present in the excited state. So the atoms cannot go from the ground state to excited state without any external energy. So we have to give some external energy by giving that that can move to the excited state. So that process is called the pumping mechanism. So with the help of pumping mechanism we can achieve the population inversion. So here we have the thermal equilibrium. So at equilibrium, lower energy states are more populated with the Boltzmann distribution law, that is N2 by N1 is nothing but the B21. The challenges for laser action, we need N2 should be greater than N1 always. The atoms present in the excited state should be greater than the ground state. So the active solution is nothing but that requires continuous energy input, that is called pumping, to maintain non-equilibrium conditions. So here we can see the creating population inversion. So we have the different mechanism for that. So first one is optical or electrical pumping. So with the help of light energy we can induce the atom from ground state to excited state. And fast decay, so the rapid non-radiative transition to metastable state, that is E2 transition. And a population accumulation, that is long-lived metastable state that accumulate a population, so that are achieving the N2 greater than N1. So stimulated emission, so with the help of that external energy only, the atoms can move from the excited state to the ground state. So real world applications is nothing but ruby laser. So first successful laser in 1960, 3-level system using chromium ions in aluminum oxide crystal. So helium neon laser, that is a 4-level system with improved efficiency, widely used in education and alignment applications. Fiber optics, that is stimulated emission, enables long distance data transmission in telecommunication infrastructure. And medical lasers, that is precise tissue ablation and treatment using controlled stimulated emission process. So here we can see the some key equations and concepts, that is gain condition. So the condition for the population inversion is nothing but N2 should be greater than N1, and Einstein's coefficient, that we have seen how the spontaneous emission and the stimulated emissions are related to each other, and we can see the threshold condition, that is nothing but N2 minus N1, that should be greater than the losses, that is data losses. And here we have some challenges, that is assessment question. So in stimulated emission, the emitted photon has the phase, frequency and direction as the incident photon. So the answer is same. The question number 2 is nothing but population inversion means N2 should be greater than N1. The answer is B. Question 3, there is nothing but which system is more efficient for achieving population inversion. So the answer is 2-level system. So easily we can achieve the population inversion. So here we can see some takeaways. There is quantum foundation, population inversion and design thinking bridges. So in quantum foundation, spontaneous and stimulated emissions are fundamental quantum process that is governed by Einstein's coefficient that enable modern photonic techniques. Population inversion, that is we should create that mechanism by applying the external energy. So that is nothing but N2 should be greater than N1. Design thinking bridge, here applying creative problem solving framework to physics. So that deepens the understanding and reveals connections between a theory and innovation. Thank you.